All right. So let's talk about geometry problem. Okay. All right. So we have let me begin with the number 17. Okay, this is a problem from last homework. Let's see, number 17, 15. Yeah, 15. 15 is a geometry problem, but that is a coordinate geometry. Now, if you see a problem like that and have no idea, right, then you go back to the chapter, about the coordinate geometry. So at least you understand a little bit about the coordinate geometry. Then you come back to solve the problem. Okay. So the problem says that if the point was coordinates, so you just need to know what does mean coordinates. Okay, lines on the line. The line is the equation is x minus 2y equals -2. So what is the k? Okay, so this just means the meaning of the equation. If you say x minus 2y equals -2 means we are given a bunch of all the points on this line and the coordinates are related by this equation. So now if we say k -3 is a point on this line, means in the place of x you have to replace by k, in the place of y you have to replace by 3. And then you solve the problem. Okay, so then k plus 6 equals -2, and k is going to be -8. So all you have to do is just understand the meaning of the equation. Equation means if equation xy means the points on the line that coordinates x and y are related by that equation. Okay. Now, because we're talking about linear equation here, so every equation you can always express in the standard form. So let's take a look at this equation in the standard form, and how do we quickly sketch the graph? Okay, so this equation, you can rewrite it in the standard form. So x minus 2y equals -2, right? I can I can switch I can switch it. This is going to be move x to the right, left, and move -2 to the left, move 2y to the right. Okay, so x plus 2 equals 2y. Then you divide both sides by 2, so y equals 1/2 x plus 1. So this is a standard form. Okay, in my last class already mentioned that as a standard form. Standard form, okay, of linear equation. Okay, this is also called a point slope form. So this will be the slope, so-called. This will be the y-intercept. Okay. So what does it mean slope? Slope is 1/2. That means there are the change in y and change in x. So how can I draw the graph quickly using the slope? Okay, using the slope, first of all, y-intercept. Okay, so this is a 0 and a 1. Okay, now slope is a ratio of the change in y and change in the x. So we may let delta y to be 1, delta x to be 2. So that means another point on the line will give the change in x equal to change in y equal to 1. So you go to right by 2 steps and go up by 1 step. So this will be the line. Okay, that's delta y equals 1, delta x equals 2. So that's the meaning of the slope. Okay. Yeah, but of course you can find another point besides the y-intercept. Then you connect. Then you draw the line through those 2 points. Okay, so that is yeah, that is you can do. Okay. Okay. You can also find another point from the equation you're given. You let x to be 2, then you, right? Let x to be 2, and then y is also going to be 2. Okay, you can try and find another point to sketch the graph. Another point, you can let x to be 2, then y is going to be 1/2 times 2 plus 1, which is 2. So another point will be the point with coordinates 2 and 2. So actually this is a 2 and 2, and this is a 0 and 1. Then you draw the line, okay, passing through those 2 points. So if you're given the equation, you should be able to draw the line. You also can get the information, the slope and the y-intercept. You already have a slope and y one point. Just need to find another point. Okay. All right. My next problem is a proportional problem. Okay. So the question is, what is the degree? What is the degrees? The minute hand of a clock moves from between that, from 6 o'clock or 4 p.m. to 6 o'clock 21 p.m. Now you have to understand the minute hand. Okay, the minute hand is a longer one, right? This is our hand. Okay, so the minute hand rotate, complete circle will be 360 degrees. Okay, now 6. Okay, so from 6:04, where's the minute 6:04? Let me draw the picture. Okay, the 2 pictures. You have to draw the 2 pictures. Okay, so at 6:04, the wet is. Okay, this is a this is the line from top to the bottom. Okay, 6. Okay, that's a 0. Okay, and then you have to increase this is our hand, right? A little bit. Okay, so 6:04. Okay, so 6:04, you have to draw the minute. Okay, the minute hand, you see, so here's a 15, right? Right, this is a 1, 2, 3. So 6:04. Okay, it is going to be a little bit here. Okay. All right. Okay. Okay. Right. The second picture, I'm using a different color. Okay. And 6:21. Now this is a little bit the hour hand, a little bit changing, right? Okay. But the minute hand is going to be here's a 15, right? You draw the picture, right? 3, 4, and 5. 6:30 will be here, right? 6:21, 6:21, 25, 10. So 6:21, somewhere here. So this is the angle theta. Okay, this is the angle theta. Okay. Now, how many? Yeah. So you have to use the correspondence. Okay. 60 minutes is equivalent to how many degrees? The round, right? 360 degrees. Okay. Now, how many minutes change in here, right? How many minutes change here? 17 minutes, right? 17 minutes equals how many degrees? So that's the equation you have to set up, right? Okay. When the minutes increase from 1 minute, from 0 minute, okay, and all the way to 60 minutes. So the angle, the minutes hand angle rotate, right? 360 degrees. So you just get equation, okay? So you will get 17 over 60 equals x over 360 degrees. So you will get, then you solve the equation. Okay, so you have to solve the equation. And yes, okay. So they solve the equation, you will get 17 times 6, okay? Then you get 102 degrees. Okay. Now there will be more complicated problems. Sometimes they ask you to, what is the angle between, this will between the hour hand and the minute at 6:21. Now this is very difficult. This is topic from advanced math class, okay? So I just give you some idea what it means advanced mathematics. Okay, you can also find the angle between, find the angle between the minute and hour. Well, if you have time, you can try, right? So this is a called proportion problem. Okay, you have to first of all you have to figure out 60 minutes equal to how many degrees. Okay. Yeah, another geometry problem. This is about the trapezoid. So we know, okay, how do we find the formula for the area of the trapezoid, for example? Okay, I'll let my question first. Okay, remember, let's have a review first. Okay, we define the area rectangle. Okay, A times B, right? Area is going to be A times B. Then we got the area for the triangle, because this is H, that is a B. But don't memorize the formula. We just know. We want to know how do we get this formula, right? We want to know how to get this formula. Okay. Okay. So how do we get this formula? Here's the idea. Okay, you duplicate the triangle. Okay, then you get this, right? Then this is the parallelogram. Okay, so for the parallelogram, you will get the area equals B times H. The reason is you can make a rectangle, and this portion is moving to here. Okay, so you get a triangle, a rectangle. Okay, so this is the area formula for the parallelogram. Then for the triangle, right? For the triangle, you just divide this becomes the area, half of the area of the parallelogram. Okay, now for trapezoid, this is A, this is B, this is H, right? You would do the same thing. Okay, you would do the same thing. What you do is you duplicate the trapezoid, and then you get clone it, right? Then you cut this piece. Okay, you cut this piece, and then you move this piece. You move this piece. Sorry, put it here. So you make a longer rectangle, but this side will be okay, and this side will be B. Okay, so this side will be the same, and because you move that, right? So now A plus B times H will be area of this large long rectangle. And but for the trapezoid, you have to divide by 2. So that's why you get this formula. Okay, those are the formulas. If you don't know the formula, you can derive it. Okay. All right. So you have to know the formula first, right? So the question here is, if the area of a trapezoid, okay, is numerical means for that particular unit, okay, this number, forget the unit, okay, is equal to 8 times the sum of the length of its bases. Okay, so question is, what is the height? Okay, now here we forget the we ignore the units. So this is h. All right, so the area of the trapezoid will be half of a plus b times h, right? And this should be equal to 8 times the sum of its bases. So if you just write down this, then you'll see that a plus b will be canceled out, okay? Then h is going to be 16. So as you can see that, right? And I don't think it's complicated. As long as you draw the picture, you understand the formula, you can do it. So I see some students miss that problem. When you get this problem, draw the picture and record the formula for the trapezoid. If you're not sure, all you have to do is go to Google, type area of a trapezoid, then you get the formula, okay? Then you can continue. I don't see there's any reason you cannot do this problem, okay? And can you solve this equation? Yes, no, everybody knows how to solve this equation, right? Just cancel a plus b, right? All right, so this is a geometry problem. We're going to look at another one, okay? Okay, another one, this is about increased, okay, this is about a rectangle. A rectangle is created by increasing the length and the width of the original rectangle by 2 units each, okay? So you have, here's the question. Rectangle, this is original one. When you do the geometric problems, you draw the picture, okay? Increase by 2 units on each side. The length will be increased by 2 units, okay? So this is a new one, right? The numerical value of the area of the new rectangle is equal to k more than the sum of the numerical values of the original rectangle. Okay, and the parameter. Okay, now be a little bit complicated here, right? So you write down, translate the sentence into the equation, okay? So numerical value of the area. So first of all, let's write down here. The length, that's called L. The width is W. This side, L, the length is increased okay, by 2 units. 2 units, add 2, right? W, you add 2. So that's it, okay? So this is a new, each 2 units each, okay? Now, the numerical area of the new, numerical value of the area of the new rectangle, okay, area is going to be L plus 2, W plus 2, okay? The area of this one will be L times W, right? And the perimeter of this one will be 2L plus 2W. This is write down the formula here. All right, so now the question is, as the statement is, the numerical value of the area of the new rectangle is equal to, okay, so L plus 2, W plus 2 is equal to K more than the sum of the numerical values of the original rectangle's area, LW, plus the parameter, okay? Right, that's it, okay? So you write down this equation, then you solve the problem, trying to find the K, if possible. So let's do that. So multiply this out, L times W, L plus 2, okay, and the 2W, then plus 4, right? This is right-hand side. And you compare both sides, you will see LW canceled out, 2L, 2W canceled out, K is going to be 4, okay? Now, that reminds me another problem, okay? That reminds me another problem I would like to try to do here, okay? So I have a rectangle swimming pool, okay? So this pool, original, yeah, I put the water here, okay? So I know the perimeter is going to be perimeter of the swimming pool. I know it's 40 feet. Okay, we're assuming that. I'm going to add a sidewalk. Okay, okay, off the pool. Okay, okay. The sidewalk is each side have 3 feet. 3 feet. Okay. My question is, what is the area of the sidewalk? Well, what is the area of the sidewalk? Now, think about it. I don't know the dimension of the rectangle. If I know the dimension of rectangle, I can take the area of the swimming pool and take the area of the larger rectangle and then take a difference, right? That's called the subtraction method. But this subtraction method still can be used, but we don't know the dimension of the rectangle, right? But that's okay. Now, if this side is L, this side is W, okay? Then all you have to do is just express the length of the larger rectangle by L plus, I think on both sides, it's going to be, and both sides is going to be, yeah, L plus 6, L plus 6, here's W plus 6. So the area of the sidewalk is going to be the area of the large rectangle minus the area of the small rectangle. Okay? And you end up with a similar situation here. You see, look, right? So you hear L plus 2, W plus 2. So you know you multiply them out. It's L times W, L times 6, 6 times W, and 6 times 6. And you will be surprised, area of the swimming pool is gone. What is left is only 6 times L plus W, 36. So perimeter is going to be 40 feet. So half of the perimeter will be 20 feet. So then you get 120 plus 36, 156, okay, square units, okay? So that's going to be feet square. That is the area of the sidewalk. Okay, that's a very good question. Okay, so sometimes you're not given the information you need directly, but probably you can bypass that without finding them. I even still don't know what is the length or what is the width of the swimming pool, but it's okay. All I need is, after simplifying the expression, I just need the perimeter of the swimming pool. Okay, this is a very good question. Okay, it shows up in math competition many times. So you just name the variable. You don't need to know the exact value. Okay, just like the above problem. Yeah, I don't know the area. I don't know the length, don't know the width. That's fine. You just name them, and then you write down the relationship and you find out you don't need them. You bypass that, cancel out. Okay. Yes. Let's move on to the next problem. Okay. Talking about next problem, I needed to talk about Pythagorean series. And special triangles. Okay. Now the Pythagorean series says that the triangle is a right triangle if and only if, okay, it is a right triangle if and only if c squared equals a squared plus b squared. So actually, if and only means if a squared equals a, if c squared equals a squared plus b squared, then it is right triangle. Okay, so if you are given information like that, 3, 4, 5, then 3 squared plus 4 squared equals 5. So it is a right triangle, right? That's very important information. Most of students just remember the formula. Okay, if it is right triangle, then a squared plus b squared equals c squared. But conversely, it's also true. Now, this relationship is 3 squared plus 4 squared equals 5 squared was, I think, on the record, was first discovered by Chinese. Of course, the Chinese did not prove the general theorem. So that's otherwise called the Chinese theory, okay? And now it's called Pythagorean theory, okay? Chinese only got the very special one. That's what we find out in the older literature, okay? So maybe this guy is just accident to find out. It has nothing to do. And in front of the yard, he walked to the source 3 steps, then back to the starting point, and walked to the west of it. Okay. Walk to the source 3 steps, and back to the origin point, and walk to the east for 4 steps. Then he find out accident maybe discover that along the diagonal, it's 5 steps. Okay, so then he said, "Oh, that's my discovery." So he wrote down. Okay, then to record it. But he did not continue to do the experiment. Actually, there are many right triangles that was the integer lenses. Okay, was integer lenses, and yeah, let's try this. So we are given another one. Okay, and this is going to be 17. And let me draw a different way. So it should be matched with it. Yeah. Okay. Now we are going to get, okay, this is a YZ is 10, and X yeah, let me give you a problem. So let me give you another problem. Okay. Yeah, I'm trying to make it. Okay, 12, 13, and 12, and 5. All right. Let's check whether this is going to be right triangle or not. Okay. So 5 squared plus 12 squared is 25 plus 144. Is going to be 169. That will be 13 squared. Yes, it's the right triangle. Yeah, so this is a right triangle. Okay, it's a right triangle. So if it's a right triangle, if I draw the line, can we find the height? Okay. Okay. All right. Now, it's not a trivial, right? Then what is the best way to solve the problem? The best way to solve this problem is to find the area of the right of this triangle. We know this is the right triangle, so the area is going to be 12 times 5 divided by 2. Because why? 5 is going to be height of this triangle. You can put it in this way, right? Here's a 5. That's 12. That's a 13. So this is a triangle, right? How does it look like when you rotate it? So base times height divided by 2. But on the other hand, 13 can be viewed as a base. So that would be the base times height. From that, you see, you calculate area in 2 different ways. Okay, using the same formula, but use a different basic. Okay, then you will get it's 12 times 5 divided by 13. 1/2 is gone. Okay, which is 60 over 13. So that's how do we find the area. Okay. All right. So our next problem will be, here's a picture. Okay, here's a picture. And we know that this side is 17. Okay. And I'm going to draw a height here, 8. Okay. Okay. So I know that this part is going to be 15. Okay. I also know that this part is 10. Can we find out h? Okay. If we can find the h, can you find out this? This called the b. Okay. Find h and the b. So you can figure out all. Okay. And then maybe later on can you find the area, okay, of this larger triangle, okay? Then and then the area also. All right. Yes. All right. So 3 things we have to find out. So step by step, if I just give you this picture, say what is the area of the triangle, you probably say, oh, it's not. You have to find lots of things, right? All right. So by the Pythagorean series, right? Area. So 15 square plus h square equals 17 square. Okay. So you needed to find out this. Okay. So you will get, use a calculator. If you don't use a calculator, and I can show you here's another quick way. 17 minus 15, 17 plus 15. It's better. I don't need to square it. So that will be 2 times. Okay. And this is going to be what? 7 plus, that's going to be 2, 32, so 64, okay? And that h squared. So that's how do I get h squared, okay? So h is going to be 8. Now, once you get 8, then you can get a b. Also by the Pythagorean series, right? 8 squared plus b squared equals 10 squared. I think a b is going to be 6, okay? B squared is going to be, it's going to be 60, right? 100 minus 64, that's a 36. So B is going to be 6. Okay, so let's go back to the picture. So here is 8. That's going to be 17, 10, 15. That's a 6. Okay, so the area is going to be 1/2 15 plus 6 times 8. Okay, so will be 21 divided by 2 times 4 multiply. Yeah, it's going to be 84. Okay, so 84 is going to be the area. This is a pretty good question. Okay, Now, yeah, so, all right, just apply the Pythagorean Series, and you can step by step, you can solve the problem. Now, in an advanced math class, I probably ask you an arbitrary triangle with 3 sides given, and what is the height of the triangle? Okay, what is the height of the triangle? Yeah, I just randomly pick up a triangle. Okay, so here's a 5, here's a 7, okay, and here probably is 9. And can you tell me the height? What is h? Aha, what is h? Right, so h is not going to be integer. Okay, how do you find it? Okay, how do you find it? Any idea? Okay, if you are able to find the area is going to be half of 9 times h. So if you know how to find the area in a different way, then you solve the problem. I'll make it a little bit easier. I'm going to put a 4 here because otherwise the numbers are ugly. Okay. Okay. Now, I wish you memorize this formula. That's called the Heron's formula. Okay. You let S to be the half of the perimeter. Then the area is, the formula is pretty simple. Okay. So that's a formula. So therefore, for the above problem, you will get 7 plus 9 plus 4. 7 plus 4 is 11, 11 plus 9 is 30, 30 divided by, sorry, 11 plus, so 10, this is a 10, not, okay. Okay, 20 divided by 2, 10. So the area is going to be 10, 10 minus 7, 10 minus 9, 10 minus 4. Okay, so let's see what we can get. That's a 3, that's a 1, that's a 6. Okay, not too bad. This 2 times 5, 3, 2 times 3. So how many 3s there? How many 2s there? I have a 2 2, so it's 2 times 3 taken out, and 5. So it's going to be 6 over square 5. Okay, so that is the area. So once you get the area, then you use above formula, right? So area is going to be half of 9 times h. Okay, then I get h and 12 square 5 divided by 9. Okay, so that is the height. Okay, the square root. So now you know how to find the area, right? If you haven't learned this Heron's formula, and then the formula itself is it's easy to memorize it. Okay, just half of the perimeter. Then you put inside, there's 4 factors here. All right. Yeah. So let's take a look at the next problem. Yeah, this is an interesting problem. Okay. Right. The geometry problems usually can be converted to algebra problem. Okay. So here's a question. The perimeter of a rectangle is 8 times its width. Okay. Now, if the area of the rectangle is 243 inches, square inches, 247. What is the width? Okay. Okay, so many quantities here, right? Step 1, to solve a geometry problem, draw the picture. Step 2, name the variables. For a rectangle, you name this one is W, this one L. L means length, W means width. Okay, that's the second step. You have to follow this procedure. Then you can solve the problem. Then you translate each sentence in the problem and the question. Okay, the perimeter of the rectangle. Okay, perimeter of the rectangle is equal to 8 times the width. Okay, you write down one equation. The area of the rectangle, L times W, equals 243. So you are given this, and you're trying to find out what? Find out the width. So you convert the geometry problem immediately into an algebraic problem, and you have two equations here, right? And I think you have this ability to solve these equations. Those equations. Okay, so how do you do that? Well, there are two complicated equations. Well, maybe not. So let's simplify the first equation. 2L plus 2W equals 8W. So I move 2W to the right-hand side. So 2L equals 8 minus 2, 6W. Then I simplify a little bit. L is going to be 3W, right? Okay, that's the relationship between width and length. Now, you can put into an equation, right? Into the equation. So LW equals 243. So this L will be replaced by 3W. 3W and then W equals 243. And W squared equals 243 divided by 3. And this number is divided by 3. You know why? That's another question. How do I know this is divided by 3? Okay, the sum of the digits is going to be divided by 3. So 2 plus 4 plus 3 is going to be 9. 9 divided by 3. So I guarantee it is divided by 3. I'm not going to, yeah. And then maybe I will get surprised, right? So 81. Okay, so 81 is a perfect square. So W should be equal to 9. Okay, that's how to solve the problem. Okay, so we got two equations, and but we can solve it, right? And once you get W, you can get a length. You know, yeah, you can also get a length. Length is 3 times 9 and 27. Okay, so this is a rectangle. It's 27. Okay, so 9 by 27. Yeah, so there are lots of questions about rectangles here. You see, there's another question about rectangle. This actually is an algebraic problem. All right. Yeah, remember, write down, draw the picture. Okay, name the variable. You don't know the dimension, but just call it length, L. You know, right? And the W. Then you write, but you have to translate the given information into equations. Then next step is trying to solve. All right. All right. Here's another question. Okay, we want to count the number of the, how to pronounce the number of the chords. Okay, you have a bunch of points: P1, P2, P3, P4. Okay, and yeah, how many chords you can to draw, okay? So in this case, I can draw this many, right? But if I increase the numbers of points, and can you figure out the general formula? Okay, can you figure out the general formula? All right. Yeah. So you have to derive the formula in general. Suppose you have n points. Right now, for the problem on the test, there will be 8 points, right? How do you do that? So here's a point. From the point P1, how many you can draw? Depends on how many points here around, right? So you can draw, if we have that, yeah, given n points. So except for P1, you have an n minus 1 points here. So there, for each point Pi, there are n minus 1 lines, okay? Well, associated with this period, from period, okay? From Pi, okay, that's one, okay? So that's it. If you know this, then how many points there are? N points, so n times n minus 1. But be careful, if this one start from LP1, when you look at the P3, you get another one, P3. So there'll be, if you just say n points, for each point you get n minus 1 chords, right? And then you have n points, so you multiply by n. But then you will see that each of them is double counted. So that's what you have to do by 2. So that will be the answer. So this is a number of, the chords. Right, so once you get this formula, let's derive by itself, then you solve the problem. So here's a question, right? You have 8 points. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Then how many of them you can draw, right? This is too complicated, right? Just a lot. So n equals 8 times 7 divided by 2, right? So that's going to be 28. But you cannot draw 28, such too many. So this is how do you solve the problem. Okay. My question, can you derive the formula? This is an n polygon. Okay, and convex n polygon. Okay, convex. Convex means like that. It's not going to be like it's not be like that. Okay, this is not convex. Okay, convex means means convex. Okay, so you have so many n polygons, so therefore was n vertices. Okay, in an n polygon, how many diagonals are there? Okay, so that means one, and let me show you, this is diagonal, okay? This is diagonal. This is also diagonal, okay? As long as this is a line segment not on the edge, that's called a diagonal. Okay, please go ahead. Give me the formula. If you memorize the formula, it's fine, but if you don't memorize the formula, express the capital N in terms of this little n. Okay? I have some students show me the answers. No, this is yeah, talking about 28. That's the original problem. But I'm talking about this new one. Okay, not 8 points. I have a n polygon. So this is a how they get, right? P1, P2, P3, right? P4. So the idea is you connect, from P1, how many diagonals you're going to get. But you cannot connect to P1 and P2 and the Pn. So you have to minus 3 points. Okay. So n, okay, not, yeah, n and P1 cannot connect to connected to P2 and the Pn. So besides P2, P1, Pn, you have n minus 3 points. Okay. So from each point, start from each point, you have n minus 3 diagonals. How many points there are? There are n points. Then each of them, each diagonal will be double counted and divided by 2. Okay? Yeah, divided by 2. So if we have an 8 polygon, if n equals 8, okay, and the number of the diagonals you're going to get is a 5 times 8 divided by 2. Okay? So you're going to get 20 diagonals, not 28. Okay, 20 diagonals. So that's how do you get, 20 diagonals. Well, I discussed a geometry problem from last homework and some, related topics. Okay, I will. So when you do the homework, remember, okay, don't give up immediately when you see a problems. As I show you, see, as long as you understand, it means you are able to do it by yourself if you spend extra time on that. Okay, if you can spend extra time on that. Okay. So here's my question. Okay, here's my question. So I have an isosceles triangle. Isosceles triangle. And this side is A, this side is B. Okay, this side is C. Okay. If I know the perimeter is going to be fixed. Okay. My question is, what is the smallest possible what is this is a more challenging problem. What is the smallest possible area you can get? Wow. Yeah, this is a difficult problem. Okay, but let's work on the last one. Okay. Okay. So the perimeter is fixed. Okay. The perimeter is fixed. I want to know the smallest possible area. Okay. You cannot make and this A and B must be integer. Okay. Otherwise, it's going to be 0. You know why? If A, B are not integer, why it's 0? I can make the one almost like that. Okay. Almost equal to 9. Equal to 9. And this one is so tiny. Okay. Then the area is going to be 0, right? Okay. So if you get this idea, I think based on your experience, what you can get. Based on experiences, you try to make the base as small as possible, right? Okay, and then both sides equal must be integer. So the next level of this will be 8 and 8. That should be 2. Okay. Yeah.
Oh my God, what happened?
Okay. All right. So yeah, then are you able to calculate the area? Okay. So today is the last class. Okay. So I do see. I try to ask some questions. Ask a call of students' name, and I have a couple of students without name. Okay, this is not allowed in the future. Okay, if you continue, one student is called anonymous, another one is with a Z. I don't know who you are. Okay, Alex, do you know how to find the area of this triangle? But based on experience, right? I know this should be, I make it, but this is not a proof. I just based on my experience. Okay, if I can make the isosceles triangle as narrow as possible, then I'm going to get rid of the. I'm going to make the area as small as possible. But this may be not true. Okay, you have to you probably okay. You have to prove that. There are so many different possible triangles there. Okay. All right. So yeah, let's solve it. Okay. So if you know this is a isosceles triangle, how to find the area? Okay. So first of all, you draw the height h, right? Then you get a very narrow right triangle. This side is 1, that side is h, that is 8. So h squared plus 1 squared is going to be 8 squared. Okay. So h squared is going to be 63, right? So h is going to be square of 63. 63 is 7 times 9, so it's 3 times square of 7. Okay. Right? Yeah. Then the area is going to be half of the base times the height. So that's just 3 times square root of 7. So we are not, this is not a complete solution. You may have to prove that there are others, right, isosceles triangles is going to get a larger area. Okay, this is the smallest one. So if you increase the base, each time have to be increased by 2. Then you get the next one. Okay, so before, right? 18 minus 4 is going to be, that's 7. Then you look at another one, okay? Then h is going to be 7 square minus 2 square, 49 minus 4, 45, okay? 45, then the area is going to be half of the base times square 45, and which is, I think it's larger than 2 square 45 should be larger than this. Okay, so you're actually increasing the area. Then you stop there, based on experience. Okay, and actually it's getting larger area. Maybe, but there's another case. I saw triangle is this another extreme case you have to look at. Okay, another extreme case. Okay, this one, and how to how to make this one very lower, lower triangle. What is large? Yeah, what is lowest? The height is the shortest. Okay, can you do that, right? So 18 divided by so 18, right? Total is 18. 18 divided by 3 is going to be 6 each. Yeah. So what is this number, right? So that will be 4 equals 18. I think I'm going to get so this will be 5, 5, and 8. Okay, and you can also calculate the area, but this area will be much larger than that. It cannot decrease to 4, 4. Then other one will be 10. 4, 4 does not make a triangle. Okay, 4, 4, 10. You do not make a triangle. This is the lowest one, and you do the calculation. H is going to be 5 square minus 4 square, and that is going to be 3. So the area is going to be half of 8 times 3, and 4 times 3 it's 12. So this is also larger than the number you got. Okay, so the answer will be this one. Okay, let's stop here.